All right, we are going to look at fluid resistance, specifically how do I get a velocity versus time function out of something that's going through a fluid, so air resistance, for instance. So that's the example we're going to do. We're going to drop something, and it's going to be experiencing gravity, but as it starts to fall, its speed increases, and we get some air resistance that's equal to BV. Okay. And that air resistance, you'll notice, is in the opposite direction that it's going. And so I'm going to choose down as my positive direction. That way my V is always positive. So when I create my equation here, I have mg minus bv. Okay? Meaning my force is in the opposite direction of my velocity. And so that's a vector now, equals ma vector. And we want to go ahead and we want to get a function for time. Now the problem we have here is our velocity function right now is dependent on the acceleration function, or the acceleration function is dependent on the velocity. So we kind of have an issue there. So I'm going to show you how we solve through that. All right. So one thing I want to get at before we start solving this is we have to talk about terminal velocity again. So Vt, the terminal velocity for this one is going to be mg divided by b. So basically we're saying the acceleration is 0, solve for v, that'll be the terminal velocity it reaches. And I'm going to go ahead and I'm going to make a substitution when I'm solving that using that terminal velocity. So here we go. So first step is I want to go ahead and get mg minus bv equals m dv dt. All right. So I'm going to go ahead and I really want to just take an integral with respect to time and velocity and get myself a function. So first step is I'm going to go ahead and I'm going to divide everything by b. Now in doing so, this b cancels out, and you'll notice here that I have my terminal velocity. All right. So now I have Vt minus v is equal to mb dv dt. Now, I don't like having a negative with my v, so I like to go through and I like to multiply everything by a negative here. All right, so we've kind of flipped some signs around. The next step is I want to split up the dt and the dv. So I want to get the dt over on this side, and I want to get this thing with the v over with the dv, because I'm going to take the dv integrals on this side and the dt integrals on this side. So we're going to go ahead and we're going to divide this over. I'm also going to flip the side that I have this negative m over b on. So I'm left with negative b over m. So I've moved that to the other side. dt is equal to dv divided by v minus vt. All right. So we're going to divide the negative vt plus v. I'm going to make it v minus vt, but I'm going to divide it over. I'm going to multiply both sides by the reciprocal of mb, and then I'm going to multiply both sides by the negative to get rid of that negative, and then I'm just going to multiply the dt over. All right. It's at this point that I have, anything that had a t in it, there's nothing. So I just have the constant here. And then on this side, I'm going to be having dv's, and I got to have my v's on this side. All right. The next step is I'm going to want to integrate. So I'm going to integrate from a time 0 to a time t, and from a speed v of 0 to a speed of v. All right. So here we go. Let's go ahead and take this integral. So I'm going to move up to this spot on the board. So I have negative b over mt minus 0 on this side is equal to, and so on this side I'm going to have the natural log of the bottom, so v minus vt, evaluated from 0 to v. So this side was kind of easy. This side's a little different, so let's keep going there. So I have negative b over mt equals the natural log of v minus vt minus the bottom, so I plug in 0, so this will be the natural log of negative vt. Now, I'm subtracting natural logs. That means I can kind of change that around a little bit here. And so I have the natural log of v minus vt over negative vt. Right. My goal here is I want a function of velocity, so I'm on my way to solve for this v. I'm trying to get that v by itself. So I'm going to get rid of the natural log. So I have e to the negative b over mt is equal to v minus vt over vt. Negative. Move that vt over. All right, so I have, and then I'll add this one over. So I'll have vt minus vt times e to the negative b over mt. Oops, t got kind of big there. T is equal to v. I'll factor out a vt here, and so I have vt is times 1 minus e to the negative b over mt equals v. And so there is my function for velocity with respect to time. You'll notice we have this term here, which means that our velocity is really going to kind of take off pretty fast, and then it's going to kind of peter out, and it's going to approach an asymptote of vt. Now, in real life, there's a lot more going on in the fluid dynamics sector. This is a very idealized situation, but that's where we're going to start.